Did you know that up to 35 of AI-300 operationalizing machine learning and generative AI solutions candidates fail their exam on the first try? Will you be one of them? Not if you prepare the right way. Let's see if you can answer these real questions from our practice tests. Question 1. A multinational company is deploying several machine learning models across different geographic regions using Azure Machine Learning. They want to create an MLOps infrastructure that ensures isolated experimentation environments for regional data scientists while maintaining centralized control over compute resources and compliance policies. Which approach to creating and managing Azure Machine Learning workspaces best meets these requirements? A. Create a single Azure ML workspace in a central region and use separate Azure ML compute clusters for each region's experiments. B. Create multiple Azure ML workspaces, one per region, each with its own compute targets and data stores, managed independently by regional teams. C. Create multiple Azure ML workspaces, one per region, for isolation and independent experimentation, and configure Azure policy and role-based access control RBAC at the subscription level to enforce centralized compliance and resource management. D. Use a single workspace and implement environment isolation solely through Azure ML datasets and experiment tags for regional separation. What's your answer? Take a moment to think. The correct answer is C. This question tests understanding of workspace architecture and governance in multi-region MLOps deployments. Option C is correct because it provides the necessary isolation for regional teams while enabling centralized compliance enforcement. A common pitfall is assuming a single workspace can effectively isolate experiments and enforce compliance across regions, which is not scalable or secure in complex enterprise environments. Question 2. You are leading a project to deploy a predictive maintenance solution using Azure Automated Machine Learning AutoML for a manufacturing client. The dataset contains sensor readings with complex feature interactions and some missing values. Your goal is to identify the best model pipeline that balances accuracy and inference latency for edge deployment. After running an AutoML experiment, you notice multiple candidate models with similar accuracy but varying pipeline complexity and feature preprocessing steps. How should you proceed to select the optimal model for operational deployment on edge devices? A. Select the model with the highest accuracy regardless of pipeline complexity and deploy it directly to edge devices. B. Choose the simplest model pipeline with the fewest preprocessing steps to ensure fast inference, ignoring minor accuracy differences. C. Use AutoML's Model Explainability and Performance Metrics dashboard to analyze trade-offs between accuracy, pipeline complexity, and latency, then select the model that best balances these factors for edge deployment. D. Manually retrain the top AutoML model using a simpler algorithm to reduce complexity, then redeploy it without further evaluation. What's your answer? Take a moment to think. The correct answer is C. This question tests understanding of how to operationalize AutoML models, considering real-world constraints like latency and resource limits. The correct approach leverages AutoML's built-in explainability and metrics to balance accuracy and operational factors, rather than focusing on accuracy or simplicity alone. A common pitfall is to select models solely based on accuracy, without considering deployment environment constraints, leading to suboptimal solutions in production. Question 3. A company is deploying a generative AI model hosted on Azure Kubernetes Service AKS and needs to ensure that all training data and inference traffic remain within a private network for compliance reasons. The AI workloads require access to Azure Blob Storage for large data sets, and the model endpoint must be securely accessible by internal applications without exposing it to the public internet. Which network configuration approach should the DevOps engineer implement to meet these requirements? A. Deploy the AKS cluster in a public subnet with a network security group NSG restricting inbound traffic to internal IP ranges only. B. Use AKS private cluster with Azure Private Link for blob storage and configure internal load balancer for the model endpoint. C. Set up AKS with public cluster endpoint and integrate Azure Firewall to filter all inbound and outbound traffic. D. Use Azure Virtual WAN to route all AKS traffic through an on-premises firewall before accessing Azure Blob Storage and internal apps. What's your answer? Take a moment to think. The correct answer is B. This question tests understanding of implementing secure private networking for AI infrastructure in Azure. Option B correctly combines private AKS clusters, private link, and internal load balancers to ensure all traffic stays within the Azure Virtual Network, meeting compliance needs. Common pitfalls include relying solely on NSGs or public endpoints with firewalls, which do not fully prevent exposure to the internet and increase security risks. Why choose our course? Because we provide detailed, scenario-based questions with deep explanations for every single option. Get instant access to 360+ questions and 6 complete practice tests. Start passing today with our 100 success guarantee.